Assalamualaikum warahmatullahi wabarakatuh. And hi, in this video we're going to show you what is determinant. So let's begin. The first method to find determinant is by formula, 2 by 2 formula. When matrix A is equal to A, B, C, D, the determinant A is AD minus BC. This is the symbol of determinants. For the simple example, given matrix A is 2, 1, 3 and 4. So, we calculate the determinant by multiply 2 and 4 minus with the multiplication of 1 and 3. So, we get the determinant of A is 5. Easy, right? So now, we move to find determinant by formula 3 by 3 matrix. It is quite different than 2 by 2 matrix. This formula is also known as Sorel scheme or cross multiplication. Given matrix A is equal to ABC, DEF, and GHI. Based on the formula given at the screen, we can see that we rewrite the first column and second column so that we get the formula of determinant by adding the multiplication of AEI plus BFG plus CDH minus CEG plus AFH plus BDI. To make it easier to see, we can draw a line between AEI, BFG, and CDH. And then we minus CEG plus AFH plus BDI. Get it? So let's move to the example. Given matrix A is equal to 4, 0, 3, negative 3, 1 and 2, and 1, 7 and 5. So the first step to find determinant by formula 3 by 3, we rewrite the first column and second column beside the matrix A. So to make it easier, we draw a line at 4, 1 and 5, 0, 2 and 1, negative 3, 3 and 7. The next line is between 1, 1, 3, 7 to 4, and 5, negative 3, 0. So, it is easy, right? So, just substitute in the formula and we get negative 6 as the determinant of A. The second method to find determinant is cofactor expansion, 3 by 3. For matrix A that's equal to ABC, DEF, and GHI, there are only two steps to find determinant. Firstly, choose a row or column which has 0 in it, and then expand the cofactor. It means we multiply ABC with its own cofactor. How to find cofactor? It is very simple. Cofactor A will eliminate the whole row and the whole column that have A, and we get cofactor A. To make it easier to see, for example, cofactor A. This row have A in it and this column have A in it. So we get E, F, H and I as a cofactor. For B, this column and row have B, so we eliminate it. So the cofactor B is D, F, G and I. Same goes to C. It's easier, right? And then we expand the cofactor and we get A multiplied by EI minus FH minus B multiplied by DI minus FG plus C multiplied by DH minus GE. For an example for cofactor expansion 3 by 3, given matrix B is equal to 3 to 1, 4, negative 1, 2, and 5, 0, and 3. To find the determinant of matrix B, determine row or column that have 0 number. In matrix B, the last row have the 0 digit, and then we determine the cofactor. So, how to find cofactor? In the previous slide, I said we eliminate the row or column of the certain number. For example, we start with the number of 5. So, we eliminate the row or column of 5. So, we get 2, 1, negative 1, 2. 2, 1, negative 1, 2. Minus with 0 and the cofactor of 0. How to find the cofactor of 0? To find the cofactor of 0, we eliminate the row or column that has 0 number. We get 3, 1, 4 and 2. 3, 1, 4 and 2. Same goes to the next number. So, we substitute into the formula and we get determinant B is equal to negative 8. Now, we move to the next method to find determinant. Elementary row operation ERO or elementary column operation ECO. The step is very simple. If we want to switch or interchange any two row or column, we must put a negative symbol at the determinant. We also can multiply a row or column by a non-zero constant k and add one row or one column to another. It's applied the same on both ERO or ECO. The table given on the screen shows how ERO and ECO works to find determinants. It's a little bit confusing, but let's take a look at the example. So, the example if A, B, C, D, E, F, G, H, I is equal to negative 2, find negative 3G plus 2I, 2H, negative I, negative 3D plus 2F, 2E, negative F, negative 3A plus 2C, 2B, and negative C. This means we want to make this matrix into the form of matrix. So, we can start anywhere. It means as long we follow the rule, it can be anything. I will start by interchange row. I interchange row 1 and row 3. So it be G, H, I, D, E, F, A, B, C. Remember, when we interchange row or column, we must put the negative symbol. Next, I multiply negative at column 3. Negative I, negative F, negative C. So, negative 1. It will be same as the form of this. Next, I multiply column 2 with 2. It be 2H, 2E, 2B. Next, I multiply negative 3 at column 1. Negative 3G, negative 3D, negative 3A. And lastly, column 1 minus 2 multiplied by column 3, we get column 1. So we get negative 3G plus 2I, negative 3D plus 2F, negative 3A plus 2C. So we take negative symbol, negative 1, 2, negative 3, 1, and multiply by determinant A. Determinant A is negative 2. So we get determinant of B is 12. Simple, right?
Now, we are going to continue on how to find determinant when the matrix is in a triangular or diagonal form. Let's recap. A square matrix is called lower triangular matrix if all of the entries above main diagonal are 0. An upper triangular matrix, however, is when entries below main diagonal are 0. A diagonal matrix is when all of the entries outside the main diagonal are 0. So how to find the determinant for all of these cases? Easy. We just multiply each entries in the main diagonal of the matrix. 1 times 2 times 1 times 3 equals to 6. 1 multiplied by 5, 3 and 1, we get 15. And lastly, 2 times 2 times 1, the answer is 4. See? Very simple. These are the properties of determinants. It is actually quite important to remember since we are going to use them in answering questions related. So please, do memorize them after this, okay? Let's take a look at the very first question and see how we can apply the properties. Given matrix A 3 by 3 and B also 3 by 3 with determinant A equals to -6 and determinant B equals to 2. Find determinant 3A cubed times B inverse times B transpose. First, we can separate the whole determinants into several parts. Then, take out the value 3. And remember, when scalar is being taken out from determinant, value need to be to the power of n. Since A is a 3 by 3, hence scalar 3 will be to the power of 3. Determinant B inverse can be converted into 1 over determinant B, and determinant B transpose is actually equals to determinant B. Substitute the value, calculate them, and bam! The answer is -5832. Next question. Find K such that below matrix is a singular. Singular means the matrix is not invertible, and according to properties, when A is not invertible, determinant A equals to 0. So first, find the determinant using any method that we have learned. As for this one, I use covector expansion along second column. Since determinant A equals to 0, we are going to obtain quadratic equation. Calculate and K will be equal to 2 and 9. Moving on to the application of determinants. We can apply the concept of determinants in number 1, finding the inverse of matrix, which is also involving adjoint method. Number 2, finding solution of a system of linear equations. Here, we are going to use Cramer's rule. Question 1. Find the inverse by using adjoint method. First and foremost, we have to find all of the cofactor for the matrix. Still remember how to do it? Well, let's see if we want to find cofactor row 1, column 1. The operation will be -1 to the power of m plus n, which is in this case 1 plus 1, multiplied with minor row 1, column 1. Hence, we get +1 multiplied 2 times 6 minus 1 times 1. Therefore, the answer is 11. Using that concept, find other values and construct cofactor of matrix. How to find adjoint? Well, adjoint equals to the transpose of cofactor matrix A. Familiar with the word transpose? Row 1 will be column 1, row 2 will be column 2, row 3 will be column 3. According to formula, A inverse equals to 1 over determinant A times adjoint. Since we already have the adjoint matrix, we just have to find the determinant A. You can use any method you like. Here, I use cofactor expansion along third row. After getting all of the elements, substitute into the formula, and we will get the answer. The last question is, solve for x, y, z by using Cramer's rule. How to answer this question? Well, let me explain to you one by one. Step number 1. Convert the equation into standard matrix. By using any method, find determinant for A. As for me, I'm using cross multiplication. S1 equals to 59, S2 equals to -2. determinant A 59 minus -2, which is equals to 61. Now, construct standard matrix for A1. What is A1? It is quite a simple technique actually. Well, basically, you are just going to replace the column X, which is column number 1, with value from constant matrix, which is the answer from the original equation. See, now column 1 consists of value 8, -3, and -11. Find determinant of A1. By using also cross multiplication method, S1 equals to -81, S2 equals to 41, and determinant of A1 will eventually equals to -122. By referring to the same concept, for A2, just replace column Y or column 2 with value 8, -3, and -11. After that, find the value of its determinant. S1 equals to -129, S2 equals to 54, and eventually, determinant of A2 will be equals to -183. The same technique applied to find determinant of A3. As you can see in the formula here, to find x, determinant of A1 need to be divided with determinant of A. Y equals to determinant of A2 divided by determinant of A. And Z equals to determinant of A3 divided by determinant of A. Just substitute the value in the formula and we'll get the answers. If we are not sure with our answer, do not worry. We can actually check by substituting the value back into the original equation. See, we obtained the correct answers. Congratulations! We have come to the end of this chapter. My team and I really hope the explanations we provide are sufficient for you to master the whole topic of system of linear equations and also determinant. Thank you so much for lending your ears. Stay safe and may peace be upon you.